Okay, so now I'm going to subtract. So I'm going to take f minus g, and then I'm going to substitute into the x variable n plus 3. So f minus g. So my f function is 2x squared minus x. I'm going to subtract g, which is 3x plus 2. Okay, let's combine like terms. 2x squared minus x minus 3x minus 2. 2x squared minus 4x minus 2. Okay, now I'm going to substitute in wherever there is an x, I'm going to substitute in n plus 3. Now, here's a really common mistake students make. They think this becomes n squared plus 9. This says write this quantity twice. N plus 3 times n plus 3. All right, so I'm going to do this the shortcut way. When I distribute and I go through and I do this by foiling, I multiply the fronts, I multiply the backs, and because these are the exact same, I take the inside and the outside, so I get positive 3n, which combines to give you 6n. Okay, I'm going to quickly distribute 2n squared plus 12n plus 18 minus 4n minus 12 minus 2. 2n squared, okay, how many n's do I have? 12 subtract 4 is 8, and then I have 18 minus 12 is 6, 6 minus 2 is 4. But I have to come back to the side and write f minus g n plus 3. Let's take a look at f. So we already multiplied these up above. So if I look straight up above, or you do the exact same, I can see that when I multiplied them, this is what I ended up with. So I'm going to start by coming back up here. And for part f, I've already multiplied them. Now I'm going to substitute in a negative 2n to the fourth wherever I see the variable x. So f, g, and I'm substituting in negative 2n to the fourth. Okay, wherever I see it here, I have 6 times negative 2n to the fourth cubed plus 1 times negative 2n to the fourth squared minus 2 times negative 2n to the fourth. Let's just make sure I wrote that down right. There's my 6. I substitute in this value for x, and it's cubed, plus 1. There's negative 2n to the fourth squared minus 2 times negative 2n to the fourth. Okay, all of that looks good. All right, so when we go about doing this and we use PEMDAS, the first thing we do is we ask ourselves, is there any work to do inside the parenthesis? And there is no work to do. So the next thing is exponents. So I'm going to write over here so I have enough room. When I distribute, it has to be distributed to both. So this is negative 2 to the third. And then when you have a power to a power, you multiply. So n to the 12th. I'll bring down the 1, same thing here. This is negative 2 squared, and n to power to a power, I multiply to the 8th. Negative 2 to the third, negative 2 times negative 2 times negative 2 is a negative 8. When I multiply, I get negative 48n to the 12th. Negative 2 times negative 2 is 4. 4 times 1 is 4. And negative 2 times negative 2 is positive 4. N to the fourth. Now this was f times g, substituting in negative 2n to the fourth. I grew up writing this a little bit different. When I look at g, another way to write this is it looks like this. This means the exact same thing. So it means I start by plugging x into g, and then I'm going to plug that portion into f. So let's start by going, what is f? That's my final result. So my final result is f. So I'm going to write down f is, but wherever I see a variable, I'm going to put a bracket or a parenthesis. So this is the final result. Now inside those open areas that used to contain a variable, I'm going to replace them with g of x, which is 3x plus 2. 3x plus 2. Okay, let's simplify. This means write this quantity twice. It does not mean you can just distribute. 3x plus 2 times 3x plus 2 minus 3x plus 2. Oops, sorry. A common mistake I did see from students earlier this week is they saw these two and they thought they could cancel them out. Remember, we need to multiply before we add or subtract. So I'm going to go through here and I'm just going to do the quick way. When they're exactly the same, I multiply the fronts to get 9x squared. I multiply the backs to get a positive 4 in this case. I can see the inside is a positive 6x and the outside is a positive 6x. 6x and 6x is 12x. Okay, I'm going to distribute the 2. So 18x squared plus 24x plus 8. And then I'm going to distribute the subtraction sign. 18x squared plus 24x plus 8 minus 3x minus 2. And here's my final answer. Again, it can be written, I'm so sorry you couldn't see that. It can be written like this, or another way to write it is like what Mr. McFarland has provided us. It could also be written like this. They mean the exact same thing. So 18x squared plus 21x plus 6. Let's look at our last one from the top half. Last one from the top half. So we're going to do the exact same thing, but instead of starting with representing F and plugging in G, we're going to do just the opposite. Again, I prefer to think of it like this, but it means the same thing. So I'm going to write down what is G. Okay, so I put down G, and wherever there's a variable, I'm going to put an open space with a parenthesis or bracket. Now, what am I going to plug in there? I'm going to plug in F. I'm going to plug in F of x. So 2x squared minus x. This is much simpler here. Since there is no exponent, I can just distribute the 3 to get 6x squared minus 3x plus 2. That's all there's to it.